Welcome to video 6.1, One Sample Confidence Intervals. So our scenario today is we have at a local restaurant, a small order of french fries should weigh 6 ounces. The restaurant owner is concerned that her employees are filling orders of french fries improperly. She would like to estimate the true mean weight of a small order of french fries, so she randomly selects 12 orders throughout the week and weighs them. The weights are given in the table below, and so these weights are in ounces. Construct and interpret a 95% confidence interval to estimate the true mean weight of a small order of french fries at this restaurant. All right, so we're talking about means here because we're talking that she talks repeatedly about the true mean weight, so we know we're having a means, and we're going to create a 95% confidence interval to estimate the true mean weight of a small order of french fries at this restaurant. Okay, now the reason I'm making that underlined there is that is actually how you're going to define your parameter. So these are our 4-step problems. In our state portion, you want to be sure you define your parameter and write down your confidence level. Okay, so we're talking about means here. So because we're talking means, that means we have to, our parameter is going to be mu. You want to make sure you use the correct notation here. And right there, it tells you exactly what to write. The true mean weight of a small order of french fries at this restaurant. Okay, so we've defined our parameter. You want to also include your confidence level. So here we're going to create a 95% confidence interval, and what that means is if we repeated this process many times of the same sample size using the same process and created confidence intervals for each one of those many samples, 95% of the confidence interval will capture the true mean weight. Okay. The other thing I also like to include here is some information. So you'll want to pause the video, put these numbers into list 1, and calculate the mean and the sample standard deviation, and come back when you have done that. So here I had an X bar of 6.367. I have the standard deviation for my sampling distribution will be 0.41. The other thing I'm going to need for this is I'm going to need a degree of freedom, because this is going to end up being a t interval, because when we're talking about means, we're talking about t. So you can include this information a couple different places. I like to get it right away to help frame my thought process. So there's 12 samples minus 1, so our degree of freedom is 11. All right, so we've got our state information. Now, one AP tip that I want to give you about defining your parameter is I want you to be sure your parameter refers to the population and not the sample. Okay, so if you look at how they ask the question, if you phrase your definition the same way they do, you're going to be fine. And in general, make sure you're using present tense. Do not use past tense, because that sounds like you're talking about the sample instead of in general. Okay, so be sure you're referring to the population and not the sample in your defining your parameter. Okay, so that gives us state. The next one we're going to do is plan, which is below state. The order you write these, sometimes we'll do state, plan, do, conclude. You can do state, plan, whatever kind of works for you to organize. That's all it is. It's an organizational tool. So in the plan, you want to identify your procedure and check conditions. So our procedure here, it's one sample of 12. So this is a one sample. It's a means problem, so it has to be a t interval, because we're creating a confidence interval for mu, because that's what we're trying to estimate is mu. Right. So our conditions here, we had random that we have to check. So when we look at random, it says randomly selects 12 orders. So we'll write randomly selected 12 orders. Okay. The next thing that we want to check our 10%, because we sampled without replacement. So 10%, remember that's how big is your sample size? That has to be less than or equal to 1/10 of all the population. So we'll say that's all fries orders at this restaurant. All right. And then the last thing we need to check is the normal, because everything's based on the normal shape, so we have to have this information. So it's a means problem. There are 3 ways we can check normal. The population can be normal, but our problem does not say the population is normal. We could have a large sample size, so your sample is greater than or equal to 30, and that would make your distribution approximately normal by the central limit theorem. We have only 12 in our sample size. So the third one is to look at the data and check for strong skew or outliers. Okay, so you need to be sure that you write this down. So what I want you to do is we're going to make our line, and this is the average French fry weight. Okay, and so you'd want to make a scale. I just counted by 0.2, so I have 5.8, 6, 6.2, 6.4, 6.6, 6.8, and 7. So what I want you to do is pause the video, go put your data, these points, on this number line, and come back when you're done. So once you have all of these graphed, you want to look at it, and so we can see how they're pretty evenly distributed across here. None of these appear to be outliers. So you want to make the statement that the sample shows no strong skew or outliers. That brings us to our second AP tip. If you're having to use this, so if you're using sample data to check normal, be sure to graph it if the graph wasn't provided to you. Sometimes they'll give you the graph and you can refer to the graph that's already there. But if it doesn't exist, you have to graph it as evidence of what you're talking about. Okay? All right, so we got our state, we got our plan. Now we have the do part. That's the part we're generally very, very good with. Do, all you got to do is calculate the interval. All right, so I'm going to write the specific formula in here. It's not actually required on the AP exam, but it kind of helps you think about what you're doing to organize your thoughts. For a confidence interval, if we look at our formula sheet, all we have is the general formula. So for a confidence interval, you take your statistic, which is your point estimate, plus or minus your critical value, which is a z-star or a t-star. So we're going to use a t-star times the standard error of the statistic. So what does that look like specifically for this problem? Specifically for this problem, your point estimate will be your x-bar, plus or minus, we're going to have to use a t-star because it's a means, and then the standard error is s divided by the square root of n. The standard deviation from the sample divided by the square root of the sample size. Okay, and so what we're going to want to do is we're going to want to plug this in. So this was one sample t-interval. So looking on our formula sheet, we're under means, a one sample t-interval. We don't have the population standard deviation, so this is what we're using over here for our standard deviation, okay, to help with the margin of error. So just so you know where the formulas came from. Now, our t star will come off of our table B, so we're going to have to look at that also. So our x bar we calculated, and we have the number over here, so we get 6.367 plus or minus. We're making a 95% confidence interval with a degree of freedom of 11. Okay, so on my table B, 95%, and I'm going to follow it up until I get to 11, which is 2.201. So that's my critical value here, 2.201 times the standard error, so our standard deviation was 0.41, divided by the square root of 12. So there's our formula set up. All right, so I always run the negative first, so I write these in the correct order. So we got 6.106 for the low end, and then for the other end, we got 6.628. Okay, so that's all we need to include in the do section. I do want to remind you how to do this on your calculator if you want to check, but I recommend you got to have everything set up. Once it's set up, it's pretty easy to put in the calculator, but I'll show you how to check your work. So with your calculator, to calculate the interval, you're going to press Stat, go into the test, and the procedure is the one sample t interval, so you're going to arrow down until you find a t interval. Okay, press enter, and we're going to enter the stats. We had an x bar of 6.367. The standard deviation was 0.41. We calculated that. Our sample size is 12, and our confidence level was 95%. So you'll enter all of that, and it will give you, here's your confidence interval. So you can double check that, yeah, we got the same thing. You know you did your calculations right. Okay, so that's all that we have for the do portion. So for our final section, our conclude, you want to interpret the interval. So to interpret our confidence interval, we want to make the statement that we are blank percent, so we're 95%. So we are 95% confident. The interval (6.106) to 6.628. Now remember, we're talking about the weight of the fries here, so I'm going to put a unit on that. Ounces captures. So from here, what is it that we were trying to estimate? So we're going to go back up here, and this is how we're going to end our conclusion. Captures the true mean weight of a small order of French fries at this restaurant. Okay, so that's when you define your parameter up front, you want to say that this confidence interval is referring back to that parameter. So that's why we want to go back and use the same language there. So we are 95% confident the interval 6.106 to 6.628 ounces captures the true mean weight of a small order of fries at this restaurant. Now make sure when you write your conclusion that you use the word confidence, confident, somewhere in there, because we are talking about a confidence interval, and that refers to the confidence level too. Okay, so just make sure you include that term. Now, there's no follow-up question on this, but probably the manager should do a little more training. Her employees look like they're overfilling the French fries, which will cost the manager money. It makes customers happy. They're getting more fries than they should be, but that could be costing the manager some money. All right, let's take a look at the back of this. All right, so in our second example, our scenario is the city council has considered changing an old law that prohibits people from mowing their lawns after 9 p.m. In order to determine if people of the city would support this change, they randomly surveyed 50 people in the survey. They find that 23 of the 50 people surveyed would support changing the law. They want us to construct and interpret a confidence interval for the true proportion of people in the city who would support changing the law. Okay, and they use the word proportion, so if you didn't catch it before when they didn't mention mean or standard deviation, this is a proportion problem, so that will help you frame your answer properly. So for proportion, you know your parameter is going to be P. And so you just want to copy that same statement here and include your confidence level. So we're going to define our parameter and include our confidence level. So pause the video and come on back when you're done with that. All right, so we just copied how the question defined the parameter for us and then put our confidence level in here. The other thing I like to put in here is my statistics and other information. That way I know I have it for later in the problem. So when I'm reading through here, they took a sample of 50, so I know my N is 50. And they had 23 out of the 50. So that's my sample statistic. So that's going to be a P hat equals 23 divided by 50, which gives me a sample proportion of 0.46. All right, so we're talking means here, we're talking proportions here, sorry. So that means that's a Z. So I don't need a degree of freedom because we're talking about proportions and they use a Z interval. So that looks like everything that will kind of get me through here. The one thing I want to point out is, just to help you remember this, that your parameter is in the question, that you should just copy it. So that's our first AP tip for today. So the parameter of a confidence interval will be clearly stated in the question. Use it. Don't try to make anything up. It's right there for you. All you've got to do is copy it down. All right, so we've completed our state portion. Now we're going to move to the plan. So remember, you want to name your procedure and check conditions here. All right, so we're talking about proportions. There's one sample being taken, one sample of the 50. So we have a one sample. Proportions are always going to use the Z table, and we're making a confidence interval. So Z interval for P, because we're trying to estimate the true population proportion. That's what that's saying for the procedure. So let's check our random. We know it's random because they randomly selected 50 people. All right. 10% because we sampled without replacement. 50 people are less than or equal to 1/10 all people in the city. I mean, that's a pretty good guess there. Okay, so we're good there. And then normal. Now this is a proportion, so we got to kind of remember how we determine this normal here. That's your large counts, N times P. So your N is 50 and your P was 0.46, which gives you 23. And then your N was 50 and your 1 minus P would then be 0.54, which gives you 27. And both of those numbers are greater than or equal to 10. So we're approximately normal. Okay, so we've met all of our conditions. So we're going to go to the do part. So in the do, you want to just calculate the interval. Okay, so earlier I showed you the general formula on the formula sheet. So specifically for this problem, your statistic is p hat, plus or minus your critical value will be z star. And then if you write this specific formula in before you plug things in, you got to be very careful here. When we're finding this standard, it's a standard error. So we have to be using p hat because we don't know the population proportion. That's what we're actually trying to estimate. So if you're writing the specific formula before you plug in, make sure you put p hats here, because the number we plug in will be a p hat. All right, so what does that look like here? So our p hat was 0.46, that's our point estimate, plus or minus for a 90% confidence level. Your critical value is 1.645. So let's just review that real quick. 90% is 1.645. 95%, which is the most common, is 1.96. And a 99%, this is for a Z, is 2.576. Those are your most common ones that you would be asked on the AP exam, so make sure you know those. So we'll go back and keep plugging in. Our p hat was 0.46, so 1 minus p is 0.54 divided by the sample size of 50. Okay, so when I calculate it out, I got 0.344 and 0.576. These need to be written smallest to largest because that's how we write these. So let's check our work on our calculator. Okay, so what you want to do, you want to go into your stat, go into your test. This is a 1 proportion z interval. So you want to make sure you get the proportion one. Okay, 1 proportion z interval. The X that we're interested in, we had 23 out of our 50 people, and we have a 90% confidence level. So make sure your confidence level says 90%. A lot of times it will default to 95% and you'll get the wrong answer. So when we go to calculate this, here we go, 0.344 to 0.576, just to verify, okay? Then our final step that we want to do is we want to interpret the confidence interval. So using the same idea that we did last time, is you want to do, we are this % confident. So go ahead and try that on your own and then come back to see how you did. So for our conclusion, we are 90% confident the interval 0.344 to 0.576 captures the what? Go back to your parameter, true proportion of people in the city who would support changing the law. Okay, so that will cover our conclusion for that. I just want to make sure one final AP tip that I've seen on a couple papers, so I want to make sure we address it, is when you're checking the normal condition for proportions, so when we check this condition right here, n times p, do not just write NP is greater than or equal to 10. That's not going to give you credit. You must prove it by plugging in the values. All right, so hopefully that was helpful. I know it was a lot. Let me know if you have any questions. I'll see you in class.